Let's talk about Project 2, Lesson 10. Engineers want to design brakes that will reduce stopping distance by 10%. How would this change the equation relating speed S, friction F, and stopping distance D? So we need to figure out how reducing the stopping distance would change these equation that engineers use to determine speed, stopping distance, and coefficient of friction. Well, the variable that we're affecting is d, distance. So if I currently am multiplying in this equation, I've got 30 times f times 1d. Think about it, what it means to reduce 1d by 10%. So if 1d is the original amount, how much of it is left if I reduce this by 10%? 90%, right? So in other words, what's 90% of 1d? And really, we're focusing on this coefficient. What's 90% of 1? So we want this to be in decimal form, and substitute that into d and simplify, and that will give us an idea of how this equation will change given that the engineers are able to reduce the stopping distance by 10%. Question 2. The equation below gives the maximum velocity in miles per hour that a vehicle can safely travel around a curve of radius r feet when the friction is F. If the velocity is greater than Vmax, the tires will slip. Engineers find that under snowy conditions, Vmax equals 15 miles per hour for a freeway off-ramp that has a radius of 50 feet. To the nearest tenth, what is the coefficient of friction for the off-ramp in these conditions? Okay. Well, we are told that under snowy conditions, Vmax equals 15 miles per hour, and we're told that this off-ramp has a radius of 50 feet. Using this information, we're asked to calculate to the nearest tenth the coefficient of friction for the off-ramp in those conditions. So use the information you know, plug it into the equation, and then solve for F, the coefficient of friction.